Hello and welcome to your controls video. As you can see, I've got all the controls here. We've also got a couple of ovens. Yes. So what I'm going to go is run through these controls quickly and give you a quick description of how they work and what's their common faults for each particular one. So first one we're going to start with is the poppet valve. The poppet valve is normally found on the top of cookers, which is where they have the lid. So when the lid is closed, the poppet valve is not pushed in, so that stops the gas from going any further and does not go up to any of the gas taps. So this is a nice simple gas tap. When the cooker lid is up, the gas will come through and it will wait in there, so it's ready to be used for the burner. Now, we have to be aware of these things because when these go to about that angle, they should shut down. So again, about that angle, shuts down. We must remember though, when we're doing a tightness test, to make sure all our cooker lids are up if we have them in our tightness test area. So the next ones, this is a thermoelectric valve. It has got a thermocouple which goes down to here. This thermocouple is basically two dissimilar metals which, when heated, have a chemical reaction and produce some millivolts. These millivolts go around this coil and back to my thermoelectric valve. So when I push this open, the pilot is ignited, it heats up, it produces the millivolts, which energizes the thermoelectric magnet at the top of this valve. So after a count of 10, we can let go and it should stay open. Next component is our regulator or governor, whichever the one the manufacturers say they are. I always call them regulators, and governors are always found on the meters. So this one is a regulator because it's on the appliance. This controls the amount of gas that goes through to these burners. Now this one is a nice simple one. Later on when we go to the other controls, we will see another one. And then the next component is, this is a solenoid valve. The solenoid valve is controlled by electricity. It works on the principle that when we get electricity and movement, this produces magnetism. And inside there is a iron core seal, which has got a big spring on it. When it's not on, the spring pushes down and shuts off the gas. But when we turn the power back on, it will open with the magnetism and let the gas through to the burner, which will allow the appliance to light. This is normally controlled by an electrical mechanical thermostat. Next component, these are found inside a cooker, which is normally located in the oven. So there you go. So it's inside these beasties here where the ovens are. So this one is a vapor expansion FSD. How it works is, there's the vial. In that vial is some liquid. When you light the burner, the vial is in the flame, and at 1000 centigrade, that liquid will turn to vapor. That vapor then expands through these little sealed tubes, which opens the bellows, which then lets the gas go through to full gas, which will then bring this flame up. This is normally done within 30 to 60 seconds. If it takes any longer than that, the FSD is faulty, or it could be the vial has just been moved out of the way. The next component that takes over though in that cooker is the thermostat. This is a mechanical thermostat, so it's a liquid expansion because it's got the vial up here that expands when the liquid gets hot, which goes into here, which opens a bellows. So it's a, as I say, a mechanical thermostat. As the bellows open with the oven getting hotter, it then reaches a point where it shuts off the valve, and it then goes to what we call a bypass mode. So where my finger is there, that is the bypass part. So that will bring the flame to a low setting. Now, common fault with these is that bypass gets blocked. When it goes down to that low setting, it actually cuts off the gas, which then this cools down, which will then open the gas up, which then lets gas come through here. And that is what the flame supervision device, the FSD, is supposed to look out for. So when this doesn't have a flame, that returns back to normal and it keeps this gas just on a low gas leak. It's still a leak, but it's only supervising it. Okay? So as I say, they are found in ovens, in cookers. Next component we have here is a back boiler and fire. On this bit here, we have the oxy-pilot, or vitiation sensing device is what they're also called. They work with a thermocouple, This tube here is known as a sniffer. This lets just the right amount of oxygen to this pilot, which lets the flame be a nice, perfect, complete combustion, and it hits the tip of the thermocouple. It also will light the burner. And as long as the air mix is perfect, that will always stay nice and blue. But the moment there is vitiated air or there is some dirt or debris inside this tube, this flame doesn't get enough oxygen, so it will then go yellow and floppy, incomplete combustion, which will lift away from the thermocouple. And then within 60 seconds, it should shut this whole unit down to safe. So hopefully you don't get your customers dying of carbon monoxide poisoning. Next component. This is your multifunctional gas valve. On this multifunctional gas valve, we have a thermoelectric valve, hence the thermocouple. So it's exactly the same as this one. It's just the grey one. Or as one of my students called it, the grey pushy thing. All right. Then we have our regulator or governor. Then we've got solenoids in here. And then we have an electrical mechanical thermostat. This is controlled by this vial up here. This is normally located inside the heat exchanger. And just like the cooker stat, as the liquid is heated, it expands. It goes into here, which pushes a bellow, which will either make or break an electrical connection, which will turn off the solenoid. And that will basically turn the boiler on, off, on, off, on, off, as required to maintain the temperature. These are also known as an on-off boiler. They're not very fancy. They're just straightforward on and offs. Also on this appliance, we have this little thing here. So this is an overheat stat. So this vial over here, that vial is connected to that one. So if that liquid inside there gets too hot, it'll expand, push against this, and you'll hear a clunk. This will then break the connections to the thermocouple, which will then turn this gas off and basically de-energize the thermoelectric valves, which fails to safe. Job's done. But you as an engineer must come in and reset them. There's two ways of resetting it. You've got the hole there that you can poke a screwdriver through. I personally don't like that. I undo this screw here, pull the covers off, and I reset it that way, because then I don't put my screwdriver near any electrics. So that is the backbore and fire. Now on this one here, this one is known as a zero governor, and it's also got flame rectification. Now, this is my zero governor controls as well as my flame rectification controls. But the main thing we're going to focus on at first is this. So this is the zero governor part. You will see there's a rubber hose that goes to the fan connection. So as the fan turns on, this creates a negative vacuum inside the tube, which will lift up our governor. The faster the fan moves, the more gas will be allowed through. The slower the fan moves, the less gas is going through. So that burner there will alight and get either more flame, so a bigger flame or smaller flame, depending on the fan speed. It all mixes in this mixing tube and then it is burnt. It is ignited by this thing here. So this is the flame rectification. So you can see them two there and you can see this rod here. These two are my spark electrodes. These will generate a spark, which will ignite the gases on this burner. If the burner ignites, the electrode also passes a small electrical current in AC voltage through the flame. And what they've discovered is that flame will then change that AC current to DC current. And then this probe here will pick up that DC current because it will travel through the flame and it will know that the flame's on. If it does not pick up DC current, this unit will shut down to safe and then we'll have to end up resetting it. These can be adjusted in various ways. I will more than likely have to go through how you adjust a zero governor at some point. But for now, this is what I'm focusing on, which is the controls. I'll hopefully make some more videos later. And I hope this helps. If you have any problems, just let me know. Thank you very much. Bye.